In 1951, a building materials manufacturer sent a letter to the USDA, requesting that a specific document be reclassified, not destroyed, not banned, reclassified, from a public extension publication to an internal agricultural survey. The distinction matters because internal surveys are not distributed to extension offices. They do not reach farmers. They do not reach builders. They stay in a filing cabinet in Washington, and nobody reads them. The document they wanted, reclassified, described a wall, not a complicated wall, not a wall requiring specialized materials, or licensed contractors, or manufactured components of any kind. A wall built from stone, and clay, and time. A wall that the Amish in Holmes County, Ohio, had been constructing since 1710. A wall that Charles S. Wheeler, a USDA civil engineer, had measured and documented in 1903, and found to outperform every mechanically assisted heating system he had encountered in 20 years of professional observation. The letter is still in the USDA archive. I have read it. The name on the letterhead is Owens Corning Fiberglass Corporation. The year is 1951. 3 years later, the document it targeted was not in the next edition of the USDA publication series. That is where this story begins, and where your heating bill comes from. Let me show you the wall first. Because once you understand what it does, the 1951 letter stops being surprising and starts being inevitable. I want you to picture the exterior wall of a standard American house built after 1955, 2x4 or 2x6 lumber studs, plywood or OSB sheathing on the outside, a layer of house wrap, vinyl or wood siding over that. On the interior face, drywall. Between the studs, fiberglass batt insulation, pink rolls manufactured by one of 3 companies that controlled 90% of the market. That wall assembly has an R value of approximately 13 to 21 depending on stud depth and insulation thickness. R value measures resistance to heat flow. A higher number means slower heat transfer. The wall slows heat from leaving in winter. But here is what that wall does not do. And this is the fact that the insulation industry has spent 70 years making sure never appears. That wall stores nothing. The moment your furnace stops running, that wall has no heat left in it. It is empty. It contributed nothing while the furnace was running, and it contributes nothing after it stops. It is a barrier, not a battery. It resists. It does not store. And the distinction is the difference between a house requiring continuous fuel and one that stays warm. The Amish wall is a battery. Here is what Wheeler found in 1903 in the Holmes County settlements, and what that wall is still doing. The exterior walls of the original Holmes County Amish farmhouses are between 18 and 24 inches thick. Locally quarried limestone or sandstone on the exterior face, cut to roughly 6-inch depth and laid in courses with lime mortar. A rubble core of smaller stone fragments and tamped clay filling the interior of the wall cavity. An interior face of either fitted stone or, in later construction, lime-plastered rammed earth. No air gap, no insulation layer. Stone, clay, lime, and the accumulated labor of people who understood that mass was the answer to cold. That wall has a thermal mass value that dwarfs anything achievable with stud framing and fiberglass. Thermal mass represents a material's capacity to absorb heat, energy, and hold it. Limestone sits at 30 BTUs per cubic foot. A standard fiberglass batt insulation has a thermal mass of essentially 0. It stores no heat. It cannot. It is spun glass fiber. There is nothing in it to hold energy. An 18-inch limestone wall absorbs heat during the day from solar radiation striking its south face. It also absorbs warmth from inside the house, from cooking, body heat, and the masonry stove firing its brief daily charge. It absorbs slowly, because stone is dense, and dense materials resist temperature change. It does not heat or cool down fast. And that slowness is the entire mechanism. Engineers call it thermal lag. The time delay between when heat enters a material and when that heat emerges on the other side. An 18-inch limestone wall has a thermal lag of 8 to 14 hours, depending on the specific stone. Heat absorbed by the exterior face at 2 in the afternoon does not reach the interior face until 10 at night. Heat from the masonry stove firing at 7 in the morning radiates back into the living space through the evening. The wall is always releasing heat that was stored hours earlier. The room temperature does not follow the fire. It holds steady. Even the same temperature at midnight that it was at noon. Because 400 square feet of limestone is releasing the energy it stored during the day into the space it surrounds. Wheeler measured this. On a January morning, at 6 o'clock, after a full night with no fire burning, the Holmes County farmhouses he surveyed held interior temperatures between 58 and 64 degrees Fahrenheit. Outside temperatures that morning ranged from 17 to 23 degrees. The walls held nearly 40 degrees of differential through an Ohio winter night, with zero fuel input after the previous day's brief stove firing. He wrote in his report that the wall behavior was, in his precise engineering language, thermally self-sustaining within the range of normal winter occupancy patterns. Self-sustaining. That was the phrase. A wall that sustains its own thermal contribution to the interior environment without ongoing energy input. That phrase is what Owens Corning needed to disappear in 1951, because a thermally self-sustaining wall is a wall that does not need insulation, and insulation was the product Owens Corning manufactured. Since 1938, they introduced fiberglass insulation to the market as a modern replacement for traditional construction. Their marketing material described stone and mass wall construction as primitive, outdated, and unsuitable for the speed and efficiency demands of modern housing. The language was deliberate. The implication was clear. If you were still building with thick stone walls, you were behind. You were your immigrant grandfather. The modern builder used fiberglass. But the modern builder also needed to keep buying insulation every time a new house went up. And the Amish builder, laying the same stone his grandfather had laid, never bought anything from anyone. Owens Corning did not need the USDA to ban the stone wall. They needed the USDA to stop telling farmers it was the better option. They needed the document removed from rural extension offices, the farm communities, and the Amish settlements, whose building practices Wheeler had spent weeks documenting. Reclassify it, make it internal, take it off the shelf. That was the request. And in 1954, the document was not in the next edition. Now, I need to tell you about a man named Jacob. Jacob is a master builder in the Wayne County Amish community. He is 63. He has built 41 structures in his working life, including farmhouses and barns. He has never used a pneumatic nail gun or fiberglass insulation. Not one structure he has built has required a thermal performance correction. Not one family has told him the house runs cold. I spent an afternoon with Jacob watching him lay a wall. The stone was local sandstone, rough cut by a younger crew member using a chisel. The lime mortar was mixed on site from proportions Jacob knew from memory, because his father had taught him and his father's father before him. I asked Jacob what R-value he was building to. He looked at me with the patience the Amish reserve for questions from a different framework. He said he did not build to R-value. He said he built to thickness. In 60 years, he had never been cold in February. He is right. And the insulation industry has spent 70 years making sure that measurement never appears on a building permit application. R-value is the industry's measurement. It measures what their product does. It does not measure what their product fails to do, which is store heat. There is no box on a building permit for thermal mass. There is no code requirement for thermal lag. There is no inspection point where a building official measures the heat storage capacity of the wall assembly. Because if there were, fiberglass batt insulation would fail the test catastrophically, and an 18-inch stone wall would pass it without qualification. The absence of thermal mass from the building code is not an oversight. It is the result of 70 years of industry participation. The International Energy Conservation Code specifies minimum R values for wall assemblies in every climate zone. It does not specify minimum thermal mass values. It evaluates walls exclusively on their resistance to instantaneous heat flow and says nothing about their capacity to store and release heat over time. That is not a neutral technical decision. That is a code written by people who sell the product that scores well on the test they designed. The Passive House Institute in Darmstadt, Germany, has been monitoring residential building performance across Europe since 1990. Their data shows that high thermal mass wall assemblies reduce peak heating demand by 32 to 47% compared to insulated stud frame construction. Two walls that scored the same on the American Building Code's primary metric produce radically different outcomes because one stores heat and the other does not. On a $1,400 annual heating bill, 47% is $658 that does not get burned every year for the life of the house. The Passive House data has influenced code revisions in Germany, Austria, and Switzerland. It has not influenced a single revision to the IECC, and the building products industry sells insulation, not stone. Now, the retrofit question. Because I know this is where most of you are. You live in a house with 2x6 walls and fiberglass batts, and you cannot tear down the exterior and rebuild in stone. There are three things you can do to the walls you already own that capture the thermal mass effect without structural modification. The first is interior thermal mass addition. The simplest version is a layer of natural hydraulic lime plaster applied directly over existing drywall. Natural hydraulic lime plaster has a density approximately 8 times that of drywall and stores meaningful quantities of heat relative to its thickness. A half-inch application adds measurable thermal mass for a material cost of between 40 and 80 cents per square foot. On an average room, the total material cost runs between $60 and $90. You apply it with a steel trowel, like any plaster finish. It cures to a hard, durable surface, and it begins storing and releasing heat from the moment it is dry. The second is thermal mass furniture positioning. This costs nothing and requires only understanding the mechanism. Dense objects positioned against or near exterior walls act as supplementary thermal mass for the room. Stone or brick hearths, cast iron fixtures, ceramic vessels, dense hardwood furniture, solid stone countertops in rooms adjacent to exterior walls. None of these are building components. All of them contribute to the thermal flywheel effect that keeps a room temperature stable after the heat source has cycled off. Jacob would not call this furniture arrangement. He would call it common sense. Putting heavy things near cold walls so the heavy things slow down how fast the cold comes through. The third is phase change material panel installation. This is the modern engineered version of what stone does naturally. And it is the application that the building industry has been slowly advancing, precisely because it can be patented and sold. Phase change materials are substances that absorb large quantities of heat energy when they transition from solid to liquid state and release that energy when they transition back. The most common residential application uses micro-encapsulated paraffin or salt hydrate compounds embedded in a rigid panel that installs behind drywall or as a surface-applied board. A single inch of phase change material panel stores approximately 14 times the heat energy of an equivalent thickness of concrete. Installation requires no structural modification. The panels cut with a standard utility knife and fastened to studs with screws. The cost runs between $3 and $6 per square foot installed. That is not cheap. But on the 2 exterior walls of a bedroom that runs cold in February, the total installed cost for phase change panels runs between $300 and $600. The reduction in furnace runtime in that room, measured in multiple independent studies, runs between 25 and 40%. On a household heating bill of $1,400, with that room representing a proportional share of total load. The payback period is 2 to 3 winters. After that, it is money that stays in your account every February instead of going to the gas company. Jacob would look at phase change material panels and see no difference in principle from what he does with stone. Dense material stores heat and releases it slowly. He uses limestone because it is free on the property and has been working for 4,000 years. If you do not have a limestone quarry on your property, there are other options. He would understand that. Wheeler understood it. In 1903, he documented it with precision and care. In a government survey that he published, he assumed that the farmers and builders who read it would use the information to build better houses. He had no reason to imagine that a corporation would read his findings and see not an opportunity, but a threat. Owens Corning introduced fiberglass insulation in 1938. Wheeler's 1903 survey was still in circulation, still being reprinted in state extension guides. It was still reaching the rural builders who were most likely to read it and act on it. In 1951, Owens Corning wrote a letter asking the USDA to make that stop. In 1954, it stopped. What replaced it was a framework that measured walls in our values and specified fiberglass batts by climate zone. It said nothing about thermal mass, thermal lag, or the capacity of an 18-inch stone wall to hold 40 degrees of temperature differential. Jacob has been building those walls his entire career. He learned from his father. His father learned from his father. The knowledge did not require a government extension publication to survive in the Amish community because they learned building from the man standing next to them. That transmission chain goes back to Holmes County in 1710, and before that, to the Bernese Oberland in the 16th century, and before that, to the Roman builders who understood that stone stored heat, and the Greeks who built their houses into hillsides to use the earth's thermal mass, and the Anatolian farmers who piled stone around their structures 8,000 years ago for the same reason. Every civilization that has ever dealt with cold arrived at this independently. Stone stores heat. Mass is the answer. The wall that heats itself is not an invention. It is a rediscovery of something so obvious that human beings figured it out on every continent. In 1951, a corporation that sold the alternative wrote a letter asking the government to stop telling people about it. The letter worked for 70 years. Drop your state and the construction type of your exterior walls in the comments. Wood frame, concrete block, brick veneer, whatever your house is built from. because the thermal mass question looks different for every wall type, and I want to give specific answers to as many situations as this channel reaches. And tell me what you pay for heating in the coldest month of the year. Not the annual average. The worst month. Because that number is the clearest measurement of what a wall that stores nothing costs, compared to a wall that stores everything. Hit subscribe. Because next week I am going to show you the one element of the complete Amish thermal system that ties the floor, the wall, and the stove into a single integrated mechanism. The element that the American building industry commissioned a study on in 2003, received the results, and buried them in a committee report that has never been cited publicly. I found that report in a university archive in Vermont, and what it says about the combined performance of these three systems together is the number I have been building toward across every video. The number is going to make you very quiet for a moment, and then it is going to make you angry. I will see you there.